Welcome back, everyone. Let's go ahead and finish out the last two proofs on this note sheet. On example 4, we have to prove that segment MD, right here, is congruent to, segment MD right here, prove that that is congruent to segment EB right there. And the information we have to go on is that AD is parallel to ME and that MD is parallel to BE, and that M is the midpoint of segment AB. Well, let's start with that last fact. I know that if M is the midpoint of segment AB, that it's going to divide segment AB into two congruent parts. So I know that AM is going to be congruent to MB. Now, why would they be telling me that these lines are parallel and that these lines are parallel? Well, I have a pair of parallel lines, and then I have a couple choices of a transversal, right? If I sketch out here that AD, so here's D and here's maybe A down here, it's parallel to EM. So here's EM. I could use the transversal DM right here, and I could say that maybe this angle and this angle are congruent. But that doesn't help me because this angle right here is not one of the angles in the triangles I'm trying to maybe prove congruent, right? It's pretty clear that if I want to prove these segments congruent, I got to try and prove that these triangles are congruent. Well, that angle doesn't help me. So maybe it's not this as a transversal, maybe it's this as a transversal that's going to help me. Because if that's my transversal for my parallel lines here and here, I can say that this angle and this angle are congruent. Now, where does that translate over into my picture? Well, that would be angle DAM congruent to angle EMB. Those are angles within these triangles, so that could be important. Now, what about the other two parallel lines? Let's sketch those out. We got this guy here, DM, and we got this guy right here, EB, that are parallel. And again, I could maybe use this as a transversal, segment EM right here as a transversal, and that would make a pair of alternate interior angles congruent. But again, that's just this angle right here, right? And that's not part of my triangle, so that might not be the route I want to go. Instead, what I might want to do, if I can get rid of that line, there we go, I might want to use, again, segment AB as my transversal and say that this angle and this angle are congruent because they're corresponding angles. So that would be angle EBM and angle DMA. Now you can notice what I have is that I have a pair of sides between my triangles that are congruent, and I have two pairs of angles, the green ones here and the orange ones here, and the angles, they're joined, their vertices of those angles are joined by those segments that are congruent. So that means those segments are the included sides between those angles. So that would give me ASA for these triangles to be congruent. Once I know the triangles are congruent, I can say that these sides are congruent because they're corresponding parts. So again, the plan is show that these triangles are congruent using this information that I kind of figured out on my diagram, and then say that because the triangles are congruent, these sides have to be congruent. So let's do that. Statement number 1, let's go ahead and start with AD is parallel to ME and MD is parallel to BE. And my reason would be given. That leads me to say that angle DAM is congruent to angle EMB, and in the same statement I'm going to go ahead and say that angle DMA is congruent to angle EBM. The reason why I'm going to combine those into one statement is because I'm going to use the same reason for both. It was the fact that those angles are corresponding angles. Corresponding angles are going to be congruent when the lines are parallel. So I'll just say corresponding angles are congruent is why these are congruent. Now, just to kind of keep track here, that's one pair of angles that I've listed. That's another pair of angles that I've listed between my two triangles. Next, I want to bring in the fact that these two segments are congruent. But I can't just come out and say that without first bringing in the given information that says that M is the midpoint of segment AB, because that's really what led me to say that AM is congruent to MB. I was able to make those marks on that diagram. I was able to say that those segments were congruent because I knew what it meant for M to be the midpoint, right? And so that should lead you to understand that if I'd made those marks, if I said these were congruent because of this word midpoint right there, it's the definition of midpoint that led me to say that these two segments are congruent. And that is my pair of sides. Specifically, it's the included sides. It's the included sides between these pairs of angles. So now I can say that triangle DAM is congruent to triangle EMB by angle side angle. And once I've said that the triangles are congruent, I can say that my segment MD has to be congruent to segment BE, right? My two yellow segments that I've marked up here, they now have to be congruent because the triangles are congruent, and those are corresponding parts of those congruent triangles. So they're congruent because of C, P, C, T, C. The corresponding parts of congruent triangles are congruent. Now let's look at the last proof. First of all, one thing you're going to want to notice is, first of all, I don't know where that yellow mark came from. Let me get rid of that real quick. I don't know what that's doing there. The other thing you'll want to notice is that I accidentally left off the angle 3 and the angle 4 markings on the diagram. That's what I'm supposed to prove congruent. I am supposed to prove that this angle is congruent to this angle. And the information that I have to go on, let's make those in yellow since that's kind of the way I've been doing these. I'm supposed to say that that is congruent to that. And what I have to go on is the fact that PQ is congruent to PS, and that PR is bisecting angle QPS. Now, what does it mean for an angle to get bisected? Remember, that means that it's going to split this QPS angle into these two angles that are congruent. And then, of course, I also have segment PR that would be congruent to itself. That would be the three pieces of information I would need, two pairs of sides and an included angle, to show that the top triangle and the bottom triangle are congruent, which would let me use CPCTC to say that these two angles are congruent. So let's write that out. First of all, PQ is congruent to PS, and that's given. Then we said that, well, if PR bisects angle QPS, it means that angle QPR would be congruent to angle SPR. So first of all, that's a given reason right there. And why were we able to say that these two angles are congruent? Because we knew what it means to bisect an angle. So we're going to say definition of angle bisector. Don't just say a definition of bisects, because it's really the fact that we knew that an angle had been bisected that let us say that these two angles are congruent. So definition of angle bisector would be our reason. Then we said that, oh, and also PR is congruent to itself by the reflexive property. By the reflexive property. And that was, again, that was one pair of sides here. That was a pair of angles there, and a pair of sides there. So I can see that I have two pairs of sides and the included angle. That's enough to say that triangle QPR is congruent to triangle, QPR, that would correspond to SPR, with the reason of side angle side. And once the triangles are congruent, angle 3 would be congruent to angle 4, because those are corresponding parts of congruent triangles, so they have to be congruent. So there you have it. A couple more proofs using this idea of corresponding parts of congruent triangles being congruent. If we're supposed to prove that two angles are congruent, or perhaps that two segments are congruent, one method that we can now use is try to prove that a pair of triangles are congruent that use those things as corresponding parts. And so once we prove that the triangles are congruent, I just realized I forgot to put I forgot to say triangle EMB. I said angle EMB there. Once I prove those triangles are congruent, I can use CPCTC to say that those parts are congruent. All right, we'll take a look at some more stuff next time, but for now, that'll be it.